Hello, 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 everybody. Happy Tuesday and welcome to math class. It's good to see, well, digitally see so many of you here. Today, here's what we're working on. Multiplying a fraction by a whole number, part 1. This is going to be our intro today. We're going to go a little deeper on Thursday and then even a little bit more deeper on Friday. Okay? Here's what you're going to need. Something to write on, something to write with. If you like graph paper and a ruler for making area models, for instance, you can use it. Not required for today. And then here's today's I cans. I can define multiplication as repeated addition of a given value, and I can multiply a fraction by a whole number. So let's get started with this. Let me go this way. With this equation on the board. We've got 4 plus 4 plus 4 plus 4 plus 4 equals 20. Would you agree? I certainly would, right? 4 plus 4 is 8. 8 plus 4 is 12. 12 plus 4 is 16. 16 plus 4 is 20. So our equation is true. It does equal. However, let's think about this in multiplication terms. Because we have the same value, in this case 4, being added over and over and over again. So there's a simpler way we can write it by using multiplication. We could say, and count the number of 4s we're adding. 1, 2, 3, 4, 5. And we could say instead that 5 times 4 equals 20. Again, would you agree? Right? Another way we might write that is 5 groups of 4 equals 20. You might not want to use an equal sign. We'll write out equal there, but that's kind of splitting hairs at this point. So all ways to show sort of the same action of taking a group of 4 and then adding it over and over and over and over and over again until you get to 20. In this case, 5 groups of 4, or 5 times 4. Okay? The same principle holds true for fractions. Okay? So let's say instead of 5 times 4, and I'm going to get rid of our 20 because it's going to no longer equal 20 because I'm going to change the value here. Instead of times 4, what if it was 5 times 1/4? Or 5 groups of 1/4. How would that change a repeated addition up here? What would we need to do to take this from 5 times 4 to 5 times 1/4? Right? Now, we're no longer having 4 as our kind of group size, our value, right? We've got to change all these to 1/4. And as we remember from adding fractions back in 17 years ago, aka September, right? When we add fractions, because our denominator shows the size of each piece, right? We're not going to add these 4s up, so there's not going to be a 20 as our denominator. When we add or subtract fractions, our denominator stays the same. So we're still functioning in fourths, okay? And then we add up, how many fourths do we have? 1, 2, 3, 4, 5. For a total of 5 fourths. Okay, so all of these, 5 groups of a fourth, 5 groups of a fourth, 5 times 4 would be equal to 5 fourths. Okay? And then I see in the chat as well, we can recognize here, because we have a greater numerator than a denominator, that means we have an improper fraction. Because we can take 4 of these fourths, essentially thinking about our 5 fourths as equal to 4 fourths plus 1/4, right? Here's 4 fourths. And then here's 1/4. Okay, and knowing that our 4 fourths, denominator and numerator, matchy-matchy, that equals 1. So giving us a most simplified answer of 1 and 1/4. 5/4, an acceptable answer. It's got the same value as 1 and 1/4. All we did was we took 4 of those fourths and we grouped them into a whole because it's a little bit easier to read and a little bit clearer. Okay? Now, I want to look at this in a couple of other ways here. Okay? We could also use an area model for this, right? We could say, if we have something like 5 times 1/4, couldn't we have a rectangle that is 5 units long and 1/4 of a unit wide with an area of 5/4? Certainly. And I can prove it. Indulge me for a second and let me prove it to you. If we're thinking about this as particularly this length of 1/4, let's say, for instance, I wanted to know, okay, if this is 1/4, what would 1 be in this scenario? I need 2/4, 3/4, and 4/4. Surely. Okay, each one of these is 1/4, and this whole thing has a length of 1. So if we have a 1/5 rectangle, our area is going to be what? 1 times 5 equals 5. Right? So, in theory, if this is correct, each one of these, because it's 5 times 1/4, will be 5/4. So if I added all those up, 5, 10, 15, 20/4, and 20 divided by 4 equals 5. Okay, so you don't need to prove it this deeply, because repeated addition works just as well. Being able to say 5 times 1/4, well, I'm just going to take 1/4. I'm going to add it 5 times. And that's what we're going to get. Okay? Same thing with 5 groups of 4. Okay? And if we wanted to reverse it using that commutative property, we could say 1/4 of a group of 5. Right? Here's our group of 5. 1/4 of that equals 5/4. Okay, conceptually, that's where we're coming from. Do we need to explain every single one of our problems in this much detail? Nah, we don't. Okay, but knowing that the concepts are the same, and so all the tools you can use, area model, standard algorithm gets trickier with fractions, but decimals we could certainly use standard algorithm with when we get there, multiplying decimals. And thinking about it in terms of equal groups. And if we're thinking about it in terms of equal groups, we certainly could use division to help solve this, couldn't we? Noticing here, 5 times 1/4 equals 5/4. And as we remember, our fraction sign is division in disguise. So really what we're doing is we're saying 5 divided by 4. Taking 5 things, in this case 5 stars, right? Making one group of 4 and having 1 left over. One whole group with 1 left over. Okay, so the idea with this is multiplication with a fraction involved is not so different from multiplication of a whole number. Okay, let's try a couple on the digital whiteboard here. The first one, where are you? There you are. The first one is 1/5 times 8. Go ahead and try that on your own. You can use repeated addition. How many times do you have to add that 1/5? 8 times, right? You could try it with division. 8 divided by 5, right? How many whole groups can you make? How many are left over? You could even try it if you wanted, like this area model, right? Make a box that is 8 long and 1/5 wide. And then challenge yourself to think about, oh, how many of these 1/5 by 8 boxes would I need to make a 1 by 8 box? Okay, so going ahead and taking a look at this here, if we have 1/5 times 8, we have 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5. How many is that now? 1, 2, 3, 4, 5, 6. We need a couple more. 1/5 plus 1/5. Whew! My gosh. It's a lot of fifths, right? And then add them together. Denominator stays the same. Numerator is how many fractions you've got. In this case, it would be 8/5. And can we make a group of 1? Do we have 5/5? We do. Let's circle those 5/5. 1, 2, 3, 4, 5. There's our 1, right? 5/5 equals 1. And then how many fifths are left over? With 3/5 left over. So our simplest answer in this case would be 1 and 3/5. Okay, essentially what we did here is we just divided. We had our 8 things, in this case 8/5. And we want to know how many groups of 5 can we make, because 5/5 equals 1. So we had one group with 3 left over. So 1 whole 1 and 3/5 remaining. Okay, and Ava in the chat is also reminding us that that 8 up there has a denominator. Okay, we have 8 things, and then what's the size of each piece? It's a whole. So we could put 8 over 1 there, and then just multiply straight across to get 8/5. 1 times 8 is 8. 5 times 1 is 5. Okay, same deal there in multiple different ways. Okay, big key here is remembering that when you're adding and subtracting fractions, the denominator stays the same. They're all fifths, right? If we're imagining that each of those fifths is a pack of M&Ms, right? 1 pack, 2 pack, 3 pack, 4 pack, 5 pack, 6 pack, 7 pack, 8 pack. 8 packs of M&Ms, right? The size of our pack is not changing just because we added them together. They're still packs of M&Ms. We don't suddenly have a barrel of M&Ms, right? That just doesn't make logical sense, okay? So keeping the denominator the same, and then the numerator is what you add together. Let's try one more. Down here. 1/5 now, still, times 23. Now, this one can be trickier because why? Yeah, because are we really going to write out and add 1/5 23 times, right? So, remembering, could be Ava's shortcut, could be just the general idea that, oh, look, 1/5 times 8 is 8/5. You just have the number that they are, because that's how many times you're adding it, and there's a 1 in the numerator, so we're just adding 1/5 over and over again, so it's just 1 plus 1 plus 1 plus 1 plus 1, just remembering our denominator. So in this case, we'd get fifths on the bottom, and then how many of those fifths? 23. right? And then there's our hidden division in there. Okay, 23 divided by 5. How many whole numbers can we make? We've got, if we count by 5s here, 5, 10, 15, 20, 25. Oh, we don't have 25 fifths, so we can't go that far, but we can make 1, 2, 3, 4 whole groups. So taking our 20 fifths and then how many are left over? 23. We had 23 fifths to start. We took 20 fifths and we put them into 4 groups of 5. So 4 ones. And then how many fifths are left over? So we end up with 4 and 3 fifths remaining. Okay, and this one's cool because it's a 2-digit number, so we could use an area model for this. Shall we look at it? I think we shall. Let's give this one a try. So 1/5 times 23. So we have 1/5 over here, and then we're going to put this in expanded form. 20 plus 3. And look, that kind of spells it out for us, right? We have our 20 fifths, or 20 divided by 5 equals 4. And then we have our 3 times 1/5, or 3 fifths. 1/5 plus 1/5 plus 1/5. And 4 plus 3 fifths, well, that just equals 4 and 3 fifths. Okay, if you'll notice, in all of the examples that we've used today, the numerator has been 1. Okay, because again, this is our first day, so we're keeping it simple, right? And if you have 1 in the numerator, you just have one piece of a given fraction, it becomes pretty straightforward because all you do is you know, okay, I have that many pieces, as many as are being multiplied, and each piece is worth whatever my fraction is. So if it's 63 times 1/9, we know we have 63 pieces because we're repeating that addition 63 times, and each piece is worth 1/9. So we have 63 ninths. And 63 divided by 9, or 9 times what is 63? That equals 7. Okay, so for today, and for our exit ticket today, you're going to see some problems. You can use any strategy under the sun that works for you. If it helps you to just count them straight out, great. If it helps for you to count them straight out and as you make groups of 1 to group them, love that, right? If we're doing something like, oh, I don't know, let's go with 1/8 times 23, right? 1/8 times 23, I might go, okay, let's count out our 23/8 and then make groups of 8 as we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So now we have 2 wholes and 1, 2, 3, 4, 5, 6, 7 eighths left over. Okay, so there's multiple ways to try it. If you want to try some area models today, try them out and start to kind of explore and figure out how area model works with this, because it is pretty fascinating when you think about all it is, again, is rectangles with one side has a length, one side has a width, and then you're figuring out how much space is in the middle. Okay, and even though our fractions are less than 1 for now, you can still have a length less than 1. You can have a half an inch. You can have a half a mile. You can have a third of a kilometer. You can have a fifth of a meter, or 20 centimeters, right? Okay, so good luck on the exit ticket today. If you have questions, please do come to office hour, which is starting promptly at 11 o'clock. It's in about 9 minutes from when I'm saying these words in real life. If you're watching on replay, get here as fast as you can, or message me if you have questions. And once you are finished with the exit ticket, then go ahead and jump onto iReadyMath for the rest of math time and complete some of those personalized lessons. All right. Thank you, everybody, for tuning in. We will be back here later this afternoon for science, and then our next live math lesson on YouTube will be this same time, 10:30 on Thursday. Happy math. We will see you soon.